Now let's go back to whatever we have studied, whatever you know about botany. Yeah, we studied that you plant the seed in the soil, and with the help of various innate factors, the plant growth hormones, and external factors, the seed germinates. Yes, so now it forms the system and the shoot system. Then what happens? A young sapling is formed. Yes, the leaves will start coming. The plant will start growing. And then it reaches the beautiful stage of flowering. But is it where it ends? That's it. The flowering happens and it's happily ever after. No. No. Yeah, nothing is forever. So, this beauty or this phase of the plant does not remain forever. What happens, you already know, the senescence or the aging. Aging is a natural process in human beings as well and in plants as well. Yes, we have discussed it. So now they start changing their features. You can understand that senescence is happening. The leaves will start becoming brown, there will be less metabolic activities will slow down, flowers will fall off. Yes, and that is the phenomenon of senescence. So how do we define senescence? It is nothing but the deterioration of plant organs that lead to loss of functional activity as well. Okay, so there is structural loss as well as functional loss. Why? Because plant is moving towards the death. Yes. Now, for example, but one thing about senescence I want to tell you is that it is not like one day the plant decides, okay, time to leave the world, I'm going to die. For example, in alpha alpha, the senescence could happen in steps, children. Like in alpha alpha, the shoot system undergoes senescence before the root system. Or in some other plant, it could be the root system undergoing senescence first and then the shoot system. So it is a gradual process. Remember that. Okay, just to give you a fair idea. Now, this is our favorite part. All of you people who have been revising the previous classes would love this. Yeah, because by now you know factors affecting senescence. There are three phytohormones: gibberellins, cytokinins, and ethylene. Yes, it is the time to note down, my dear children. Now, what happens is, how do they act? Gibberellin overall delay the senescence. You should write that also. Gibberellins will delay the senescence. What will cytokinins do, my children? They will delay leaf senescence. Do not forget to write down the word leaf. Cytokinins, if you remember the functions of cytokinins which we did together, remember I told you cytokinins favor leaves. Yes, they transfer the nutrients from other parts of the plant to the leaves. They enhance the production of chlorophyll. And actually, they are delaying leaf senescence. So gibberellin is delay, cytokinin is delay. What is ethylene doing? We just did it. It promotes senescence. It is one of the growth inhibiting functions of ethylene. We have already done that. So what happens after senescence? Once the plant is in the phase of senescence, the senescent parts, the old leaves, the flowers, the deteriorated parts, they have to detach themselves. They have to fall down from the plant body. And that phenomenon is called as, do you see the old leaves? They are falling down, so many leaves on the ground. This is called as, yes, you know it already, abscission. Okay? Abscission is what is abscission? It is the separation of the senesced part. Now, there is a zone of abscission created when the part has to fall down. It's a systematic thing. The region of abscission, we have given you the example of leaf. So, you know, leaf has three parts. You have studied that in morphology. This is the lamina of the leaf, isn't it? And there is the stalk of the leaf or the petiole. Petiole attaches the leaf to the stem at the node region. But this first region of the leaf, where axillary bud is present, I'm revising it all for you. It is the leaf base. So, in order to separate the leaf, there is a zone which is formed in the leaf base. Okay. Now, why abscission is needed? It is to remove the dead organ, yes. But you know what, children? If dead organ remains attached to the plant body, what will happen? Infection will happen. Why? Because microbes will come and attack this part. And they could easily spread, the disease could spread to other parts of the healthy parts of the plant. So, prevention of contraction of infection to other parts. Okay. Now, what are the factors affecting abscission? Time to pick up the pens and note down. Very important. What are the factors? We have already done that. Auxin, ethylene, and abscisic acid. So, auxin is a serious growth promoter, but it is involved in abscission. Ethylene and abscisic acid. Abscisic acid is a serious growth inhibitor. You've revised it, right? And ethylene is well on both the sides. Now, let's see their individual effects. Very, very important question. Okay, you don't want to miss this. Now, auxin promotes abscission of, I'm going to underline, old leaves and fruits. So, when the time has come, auxin is smart, I told you that time. It causes abscission of old leaves and fruits. What does ethylene do? Ethylene promotes abscission of leaves and flowers. It promotes abscission of leaves and flowers. The organs of action are different. Abscisic acid will cause abscission of everything in general because it's a growth inhibitor. Okay, so it promotes abscission in general. We good here? Note it down.